Okay, so in this lesson we're going to learn the third and final type of way to solve linear systems. We've learned graphing, where we figure out where the points intersect in a coordinate plane and then plug them in to see if we get the correct answer. We've learned substitution, where we take an equation, we isolate a variable, we plug in the equation for that variable, and then again at the end we substitute those points in to make sure that we're correct. Now what we're going to do is we're going to basically treat an equation like it's a three-digit number. So again, you'll see up at the top what we're going to learn today is solve linear systems by using elimination, and we're going to use systems of linear equations to solve a couple real-life problems in our homework. Solving a system of linear equations by elimination, we have a plan here. Again, most of this plan is pretty easy. Once you see a problem, you just kind of do it. You don't think about a lot of these steps in terms of step 1, 2, 3. First of all, we may have to multiply an equation or both equations if we have to get our coefficients to match up. Step 2, we have to add or subtract our equations to eliminate one of the variables. Step 3, solve the resulting equation. And then step 4, substitute that value into the equation and solve for the other variable. And again, there could be even a step 5 here where we can check our work, you guys. So again, we can always check our work this chapter to make absolutely certain that we do have the correct answer. So some of these first problems are set up pretty easily. Again, you guys, there's multiple ways you can do lots of these equations. If we look at this equation right here, we have 3x plus 2y equals 4, and we have 3x minus 2y equals negative 4. Now again, we could do this one of two ways. If we add, the y's are going to go away because 2 plus negative 2 is going to go away, and if we subtract, the x's would go away. What I'm going to do is go ahead and add for this example just so we can see what it looks like. So we add 3 and 3 and we get 6x. We just treat it like a three-digit number, so the x's added together, the y's add together, and the coefficients add together. The equal sign, or excuse me, the constants add together. The equal sign stays in the same spot. It's just like a two-digit number with a decimal. So now I'm going to take 2 plus negative 2 is going to give me plus 0y. Well, 0y is just going to cancel out. So that term has gone away for us now. And then we have 4 plus negative 4. That's also 0. So now all I really have is this. 6x equals 0. I divide by 6, and I get x is equal to 0. Now again, just like before, once we find one, we can find either of the others, or find the other one by plugging it into either of the equations. So I'm going to plug it into the top equation. 3 times 0 plus 2y equals 4. 3 times 0 goes away, so I have 2y equals 4. I divide by 2, and I get my solution y is equal to 2. Again, these are coordinate point answers, so write them like 1. Now we have 0, 2, and again, I'm just going to talk through this. You guys can show all the work when you go to check your solution, but notice how I'm checking my answer to make sure I'm correct here at the end. 3 times 0 is 0, plus 2 times 2 is 4. 0 plus 4 is equal to 4. That one checks out. This one, 3 times 0 is 0, minus 2 times 2 is negative 4, equals negative 4. So 0 minus 4 equals negative 4. This one checks out, so now I know it's my answer, and that took me a whole extra 20 seconds, and now I know I'm absolutely correct. Again, you can pause this one and try it on your own because this one's really not that hard. This one, it's pretty easy to see which one we want to cancel out because the other terms don't stack up and go away for us. But if you want to pause and try on your own and then check and make sure you're right, that'd be great. If not, watch me do another one, and then I have some guided practice for you here soon. This first one, it looks like we have the negative 2x and the positive 2x. Because they're already different signs for me, I'm just going to add because those different signs are going to cancel each other out. So now I have negative 2 plus 2 is going to be 0x. I'm just going to put a slash. 3 plus negative y is 2y. 4 plus negative 8 is negative 4. Divide everywhere by 2. Y is equal to negative 2. Again, I go and plug that in somewhere. I'll plug it into the top equation again. I just happen to do that all the time. So now I have 3 times negative 2 equals 4. I solve negative 2x minus 6 equals negative 4, or excuse me, equals 4. I add the 6, I have negative 2x is equal to 10. I divide by negative 2, I get x is equal to negative 5. So again, negative 5 comma 2 is my initial thought. I go ahead and talk through this real quick. So I look, negative 5 times negative 2 is 10, plus 3 times negative 2 is negative 6. So 10 minus 6, I get 4. 2 times negative 5, I get negative 10. Minus negative 2 is negative 8. So again, negative 10 minus negative 2 would be plus 2 equals negative 8. Checks out. I'm good. Before I give you some guided practice, again, you guys can rewind these and watch them over and over and over again. I'm going to show you one case where it doesn't just stack up for us nice and easy. Again, there's multiple ways you can do this. It doesn't matter whether you eliminate the x first or the y first. Just because the x's are the same sign, what I'm going to do is change my equations so that I can eliminate the y's by adding. Notice here that the 5 and the 10 are both negative. So I'm going to leave those the same sign, and I'm going to leave these different signs. Whenever the ones that I'm going to eliminate are different signs, I can just add. When they're not this different sign, I have to subtract because there will be a double negative. So here's what we're going to do. I'm going to multiply this top equation by something to make it so that the coefficient is the same. I'm going to multiply it by 2. When I multiply it by 2, that's a 2 there, sorry guys, I'm going to rewrite that equation as what it will be after the 2 is taken all the way through. So the 2 is going to be taken times negative 10, 2 times 3, and 2 times 1. So my new equation is negative 20x plus 6y is equal to 2. And then I rewrite my second equation, negative 5x minus 6y equals 23. Everything stayed the same. Notice my signs stack up where they're different. When they're different, we can add because we want to keep them different. If they were the same, we would subtract to make them have to be different so they go away. So on this one, again, I can just add the 2 up. I have negative 20 plus negative 5 is negative 25x. The 6's go away, so I'm just going to put a slash. And then 2 plus 23, I get equals 25. I divide by negative 25, and I get x is equal to negative 1. Once I find that, I can plug it into any equation. I could plug it into any of these or the ones up top. So I'm going to go ahead and plug it into the second one this time. Negative 5 times negative 1, that's a negative, times negative 1 minus 6y equals 23. Negative 5 and negative 1 is 5 minus 6y equals 23. I would subtract the 5y, so I get negative 6y is equal to, subtract, let's see, I would get 18, and I would get y is equal to negative 3. So my solution is negative 1 comma negative 3, and I'm done. Again, we have to change this one around just a little bit. Notice that the x's and the y's are not both as easy to do. Sometimes it will happen where you have to multiply both equations, but if you can help it, try to avoid having to do that. So if I wanted to get the y's to be the same, I'd have to multiply the whole top row by 5 and the whole bottom row by 2. Or I could just multiply the whole top row times 2. I could multiply that whole top row times 2 to make those coefficients both positive and negative 6. So I'm going to rewrite my top equation after multiplying. I get 6x plus 4y equals negative 4. My second one stays the same, negative 6x minus 5y equals 2. I stack them up. I can add because they're different. These go away. Then I get 4 plus negative 5 is negative 1y. Negative 4 plus 2 is equal to negative 2. So I get y is equal to 2. I plug that in. I can plug it in up here. 3x plus 2 times 2 equals negative 2. I multiply 3x plus 4 equals negative 2. I subtract the 4, 3x equals negative 6. I divide x is equal to negative 2. So I get negative 2, comma, positive 2, because again, this y down here was positive, this x up here was negative. Pretty straightforward whether you have to multiply or not multiply. Again, we're still just treating this like a 3-digit number. 1, 2, 3. So now it's your turn, you guys. Pause the video on a piece of paper, work these out, make sure you know what's going on these. This, again, it's important to make sure that we practice on our own before seeing someone do it for us over and over again. That way when it comes time to take a quiz or a test, we have all these different methods learned. Okay, so I'm going to go ahead and work these out. Number one, this is going to be pretty straightforward, so I'm just going to actually work it out right up here. I'm going to add them together because the 3's are the same coefficient. When I add, the x's go away. 2 plus 4 is 6y. 7 plus 5 is 12. So I have 6y equals 12, and I get my answer for y is equal to 2. I plug that in. 3x plus 2 times 2 is equal to 7. 3x plus 4 equals 7. I subtract the 4. 3x is equal to 3. And I get my solution, x is equal to 1. So my answer is going to be 1, comma 2. The second one, it doesn't really matter which one you multiply by, but you only need to do one, and you do need to multiply it by 3. Let's do the top one just so I can show you one of these. So I'm going to multiply the top one by 3. Again, you may have very well multiplied the bottom one by 3. You should get the same answer. When you multiply the top one by 3, it's going to be 3x minus 9y equals 24 times 3 is going to be 2. Carry the 1. Let's see. So 672. And then 3x minus y, or excuse me, plus y is equal to 12. So again, the second equation was the same. Okay, here's where it becomes a little tricky. Now, if I want to get rid of my term, I don't have to add anymore, I have to subtract. When I subtract here, so my operation is subtraction to make those x's go away. When I subtract, the x's go away, but we really have to pay attention to what we're doing. So I have negative 9 minus y, and I get negative 10y. Again, because of the negative signs and how we read them, negative 9 minus y. I know if it says positive y. If it said negative 9 minus negative y, we would end up adding because of the double negative. So I'll write that out so you can kind of see it. Negative 9 minus y. I know it says minus positive y, but this negative sign kind of overrules that positive. If it was a double negative, we'd have plus, but it's not. So hopefully you guys kind of followed that line of logic. Please make sure you ask questions if you don't. Then I have negative 10y, and then I have 72 minus 12, and I get 60. So I find my solution, y is equal to negative 6. Then I plug that in. I'm going to plug it in up here in the second equation where y is all by itself. So I'm going to say 3x minus 6 is equal to 12. I have to add 6. I get 3x equals 18. And I get x equals 6. So my solution should be 6 comma negative 6. Okay, last one. Let's go ahead and multiply and I'll show you a new way of doing this one too. Here's what we're going to do. So that we can force these signs to be different, we can choose to multiply anything we want. So what I'm going to do is I'm going to actually multiply the bottom line by -4. And you'll see what that does here in just a second. So when we multiply that second equation by -4, again, I'm going to leave the first one just the same. X plus 4y equals 22. The second equation is going to be -16x minus 4y equals... Okay, sorry, that was going to drive me crazy. I had to get a new page here. So -4 times 13 would give me, let's see, 2, carry the 1, 4 times 1, 4, 5. So it's -52, it looks like. Now what I have done is multiplied by a negative so that it would force me to be able to add these two equations and get things to go away. So x plus -16 is -15x. 4 plus -4 goes away, equals positive 22 minus 52 is -30. So when I divide, I get x equals positive 2. Then I would plug that in. 2 plus 4y equals 22. Subtract the 22, or 2 from 22, I get 4y equals 20. And I divide and get y equals 5. So my solution, 2, 5. Very many of you, most of you probably did not do it that way, but hopefully you arrived at the same answer. Again, please ask questions if you have them. Back up the video and double check those other ones and make sure you got those right as well. Again, core concept, concept summary, all those boxes are super important. This one's really, really valuable to this chapter. They threw it in at the end of 5.3 here, just to kind of help us distinguish when to use what type of method. So it talks about the different methods that we've learned. Graphing is used most of the time to estimate what solutions will be. Substitution is used when one of the variables is in one of the equations has a coefficient of 1 or -1. In other words, if one of the variables looks easy to isolate, you're probably going to want to use substitution. That's the most common one used. And then elimination is what you'll use a lot in Algebra 2 when at least one pair of like terms has the same or opposite coefficients. Or you can multiply when they can't be eliminated by adding or subtracting. And that kind of sums up this lesson. Again, please ask questions if you have some. As you can hear, my son's getting kind of restless, so I'm going to have to go battle with him for a little bit. Have a good day.